inventions of our time, a space laboratory known as the International Space Station. Like great inventions that preceded it, the station harbors the goal of improving the quality of life on Earth. At the same time, it is finding new ways to improve life in space as well, creating a bridge to the future of human exploration. The International Space Station is a fully operational home and laboratory in space. From here, crews conduct new types of scientific research that cannot be duplicated in the gravity of Earth. The lessons and data obtained from the station will pave the way for human exploration beyond low Earth orbit. It will also serve as a research platform to investigate new space system designs. Building an invention that is capable of conducting such research while at the same time sustaining human life is a complex and challenging undertaking.
To go do work in space, you need basically a power system to generate power. You need a communication system to talk to the ground. You need a research or lab facility. And you need the basic support capabilities for the human in space, and that's atmosphere, air conditioning, those type of devices.
The different parts needed for the station are constructed in factories around the world. Many elements are shipped to the Kennedy Space Center in Florida, where they undergo final processing for launch. The international effort requires meticulous coordination and planning between the participants.
We have to build and design the hardware at several locations around the country and around the world, in fact. And if those hardware can't be brought together and tested all at once at the same time. And so we tend to bring elements that maybe were built 2,000 miles apart, and the first time they see each other is on orbit.
In a remote region of Kazakhstan, a Russian Proton rocket rolls out a key station element. Named Zvezda, this is the first living quarters for the station. Once launched, it will automatically dock with two other station components already in orbit. Zvezda allows crews to stay and live on board permanently for the first time. The successful launch of Zvezda marks the start of a cascade of space flights, which launch from both Russia and the United States to bring more station parts into Earth orbit. For the last 2 years, missions to the station average about one per month. It is an unprecedented level of activity.
See the station? Wow, Steve, did you see this?
Oh no, not since Mike came.
Oh, you gotta come and see this, bud.
Getting the hardware into space is only part of the challenge. A piece at a time, the station must be put together in Earth orbit by people. The station evolves considerably from the beginning of its assembly in 1998, with each mission building upon the success of the previous flight. The station sees the addition of components providing power, air, communication, living accommodations, and a laboratory for scientific work. The architecture of the station also becomes more evident as parts of its 350-foot support truss are added a section at a time. Actually building the station in space involves a combination of techniques. Robots built by Canada move the giant station pieces into place. Both the shuttle robot arm and the station's Canadarm2 have proven to be invaluable in the assembly of the outpost.
Okay, the Johnny handles are removed. You can cover the waste ring. Okay, the drink valve position is good.
To complete the assembly tasks, astronauts don spacesuits and put the high-tech station parts together the old-fashioned way, by hand. The marked increase of spacewalks has been referred to as the wall of EVAs, which so far has exceeded over 250 hours and is continually growing. At first, astronauts conduct spacewalks on the station exclusively through a docked space shuttle. This changes toward the end of Phase 2 of station assembly, when astronauts Jim Riley and Mike Gernhardt help install the station's own airlock, called Quest, a new gateway into space.
Coming out of the station is different than coming out of the payload bay in the orbiter. When you come out of the airlock in the orbiter, you have the payload bay and the structure of the vehicle all around you. Coming out of the station, however, you're looking straight down 220 miles down to the surface of the Earth. As Mike described it during the EVA, he described it as skydiving 220 miles. You really do get this sense of nothing between you and the ground.
For the astronauts who journey to the station and for the station's crew, there is a safety net, a support team on the ground that keeps a watchful eye on every system, every operation, and every detail with the utmost care and attention. Since the beginning of space travel, this has been the job of Mission Control. From their various consoles, these highly skilled professionals send commands to the station, adjusting and monitoring station systems around the clock. When astronauts experience unforeseen technical glitches or malfunctions, ground support springs into action to find a solution to the problem, enabling mission success. The station era requires Mission Control to think beyond the fast-paced 2-week shuttle missions they were accustomed to.
Space station has taught us we're learning that transition to routine operations, trying to ensure permanency in space now, and I really do think we're there. This is a marathon and not a sprint.
As the station constantly grows and changes, control centers around the world step up to share the responsibility to support both hardware and crews.
The Russians know far more about their segment than we ever will. Canadians know far more about Canadarm2 than we ever will. So it is more complex. At the same time, there's a greater depth of knowledge out there that you get from dealing directly with the people who built all these arms.
The work of ground support allows crews living on board the station to concentrate on their primary objective, to conduct science in the microgravity of space.